In section 4.3 of your textbook, we see the title, The Nuclear Atom. It really isn't necessary to say nuclear atom because there's no difference. An atom is an atom. On the periodic table, we are going to see that we have different atoms, so we probably already know that. This block is a symbol representing an atom of hydrogen. This is an atom of carbon. This is an atom of neon. Okay, so saying nuclear just makes it sound cool, I guess. But an atom is the smallest indivisible unit that would still have the properties of the bulk material. If we were able to break down an atom, we would see that an atom is made of three parts: protons, neutrons, and electrons. The protons and the neutrons are inside of the nucleus, so that's at the center nucleus. And I'm going to write a proton as a P with a positive charge, and a neutron I'll generally write as an N. So a neutron does not have a charge, and so it sort of sounds like the word neutral. And an electron I'm going to write as an E with a minus sign. So we might remember that protons and electrons have opposite charges, and that's the positive protons inside the nucleus actually hold the negatively charged electrons, and the electrons are outside of the nucleus. So I'm going to try to draw a quick picture of that, and your book has a pretty good picture. The protons and the neutrons weigh, we have this funny mass unit or weight, and we call it an atomic mass unit. And if we notice, a proton and a neutron weigh approximately 1 atomic mass unit each. A neutron is slightly heavier. And 1 atomic mass unit is this ridiculously small number. So we're not going to talk about what a proton or neutron weighs in grams, or even what an atom weighs in grams. What I would like for us to know is that these two parts that are inside the nucleus weigh approximately the same thing. And again, an electron is outside the nucleus, and an electron weighs 0.0005446, I think, maybe that's an 8, atomic mass units. So relative to a proton or a neutron, an electron doesn't really weigh anything. So a lot of times we'll say that the electron has negligible mass. In other words, it really doesn't change the mass of an atom. An electron is similar to like a strand of your hair. So if I weigh myself on a bathroom scale, my weight is not going to change if I pluck out one of my hairs. So even though one hair does have mass, it's so much smaller than me that it really doesn't change my mass. Okay. We're also going to see that atoms are put together in a very strange way, and it's kind of hard for our brain to comprehend that. But almost all of the mass, again we can think about that as weight, is inside the atom's nucleus, but almost all of the volume or the space that the atom takes up is because of the electrons. So it's even stranger that the weight comes from a nucleus that would be about that big. So if that was the nucleus, all the weight would come from this little pinpoint, and then if I were to draw this to proportion, the electrons that are outside the nucleus take up all the room, but they don't weigh anything. So the makeup of an atom is definitely very weird. In fact, if we magnify a carbon atom so that the nucleus is the size of a golf ball, then the electrons would take up a diameter of 3 miles. So that seems crazy. And anytime we see a representation of an atom drawn, it's never going to be to scale. On the next slide, we're going to look at an atom of carbon. And so I'll be drawing the protons and neutrons inside the nucleus, and I'll be drawing the electrons outside of the nucleus.